Hello, everyone. Good afternoon or good evening, depending on where you are. Welcome to our first edition of the IEEE Cybersecurity Tips for Industry Workshop Series. We're going to be focusing on our first use case, which is the securing IoTs for remote subject monitoring in clinical trials. So I am your workshop moderator, and I also lead the healthcare and life sciences practice here at the IEEE Standards Association. Many of you have heard from me, but just in case, I am Maria Palambini, and I often write to you or you see my blasts on LinkedIn and other areas. But welcome to our workshop today. So real quick, for those of you who are not familiar with the IEEE, our core purpose is to foster technological innovation and an excellence for the benefit of humanity. Our mission is advancing technology for humanity, and that is in every aspect of the work that we do. So from a point of building standards, technical communities, looking at innovations, inspiring global communities, our main focus is how do we, either in our case in healthcare, help patients have better outcomes, but in other aspects and domains, how do we enhance their user experience, better secure them, give them right to privacy, and many other opportunities. So as an organization, we are rather large. We are 450,000 or more strong in over 160 countries. Many of you may have attended one of our annual conferences in the technical space. But as well, our work here is focused on standards development. So we have many different paths to standards here at the IEEE SA, and this workshop is going to be an example of where we're going to incubate ideas and understand where we can bring them further within the ecosystem to standardize them and make them adopted globally. So a lot of our work sits in incubation in this concept of industry connections. But actually today we are going to talk about a standard that was just published, the IEEE 2933 standard, but there's other areas of opportunity here in our ecosystem. So from an organization, as far as the SA, the Standards Association, we have over 1,500 standards and projects. We have over 380 corporate members, and we also have 34,000 global participants. For all of you out there, if you're wondering what's a standard, if you've never had the experience of working with one or in developing one, if you all take a look at your smart device, you're all using probably one of our standards, which is the IEEE 802.11 Wi-Fi protocol, which is the standard for us to connect to the Wi-Fi, for our devices to connect to the Wi-Fi anywhere in the world. Just that's a food for thought, but we have many other standards as well and obviously in our database of standards. So I mentioned that I lead the healthcare and life sciences practice. Really, we come with one major mission. When I say we, I'm talking about the over 1,000 global volunteers who work on different areas in the health value chain, looking at opportunities to integrate new technologies or new applications of technologies into either existing processes or to evaluate existing processes and how these new technologies can ultimately improve the quality of standard of life for all individuals, whether that be enhanced security, cybersecurity, of course, we're talking about privacy, access to equitable, sustainable healthcare with obviously with the growth of digital health, but as well, we do cover safe and secure, sustainable nutrition for all individuals. So today we're going to talk about a very interesting hot off the presses standard, literally was just approved a week ago, and that's the IEEE 2933 standard, and I'm going to let Florence talk about that as the group chair. But overall, today's workshop is really going to talk about how we take this standard conceptually, looking at real world challenges, right, using IoTs in real world decentralized clinical trials, and as well as look at the foundation of new technologies, where we're talking about there's all these different integration of different technologies and opportunity to not only secure the IoTs and the data transmitting from the patient's home back to the site, but also look at how we can start to partner up and how we can integrate more health data to really move towards precision or more efficiency in development of clinical research. So, but beyond that, we are going to talk about some important things, and I just want to get you all settled up before we bring on our first speaker. We're going to, obviously, as we noted, this session is going to be recorded in its entirety. The goal here is for people who could not join us live to be able to listen to it on demand when they can. The first half of this session is going to be a one-way broadcast, meaning that our speakers can talk to you all. They're going to present to you their different aspects of the use cases. You can write questions to the panelists in the Q&A feature. We will be monitoring the questions and we'll try to get all of them at the end of the speakers' presentations. I'm going to be sharing with you some interactive polling questions to get your response into some of the key challenges, which I believe will be some foundation to the second half of this broadcast, which is the brainstorming session. And this is a really important part because we're going to build the use case requirements, understanding, once Florence shares with you the 2933 architecture framework, how it can be somehow adapted into using it for IoTs in remote subject monitoring. So we have a lot to do today. We are scheduled for 2 hours, but we're going to all roll up our sleeves and get involved and hopefully move the needle forward in some of the challenges we're seeing in remote subject monitoring for clinical research. So we're going to share with you our first poll question, which is, and we're going to share the results, and hopefully I'll have some of the panelists maybe even comment if they see something that's really interesting in the data. But this will be the foundation to the brainstorming session, which I mentioned. So the poll question is, I think it's going to be queued up and ready for you. But when we think about it, it's which of the following features do you consider most critical in evaluating wearables, IoTs, or sensors for remote subject monitoring in a clinical research project? So we're really looking for one answer. Technically, you probably look at the answer and say, oh, all of the above. But really, it's the one critical element that you find the most challenging. So I think this is, really a little bit of food for thought and really pushing you guys to think which one is going to be the most challenging for us. While we get that poll question to you all, I want to just quickly go back and get our panelists queued up for you. So just as we get ready for that, we have Gilles Lutzenpfister. He is CEO and founder of Medisante. Gilles is going to talk to you about a really exciting real-world use case of a decentralized clinical trials using cellular IoTs. It was a 5-country project, and not to steal his thunder, but it was a fascinating use case, and he's going to share that with all of you. We have Ryan Wright, who is the CEO of Envelope LLC. Ryan's really going to get into now the more cutting edge technologies, looking at security at a higher, different level. But again, we're talking IoTs here, or sensors, wearables being used in the remote subject monitoring area. And of course, we have Florence Hudson, who is the chair of the IEEE 2933 standard. And she's going to talk to you about, obviously, this new standard that was just approved last week to be published. And really, they on the basis of the hospital at home framework using IoTs from that point of view. And she's going to share with you the architecture and really the hard work that whole team went behind in developing that standard. So I don't know if let me just check with my producer. Jen, did the poll question go out to the audience? Did I lose my producer? Okay. If not, I think we'll just go to, there we are. So for all of you out there, we'll give you which of the following features do you consider most critical in evaluating wearables IoT sensors? These are both single choice questions. And also, which of the following do you consider the biggest challenge in using the sensors, right? So when we say in using, so at this point, right, you all have you have your processes in place, and now here it comes to incorporate them into your study protocol, your study design, your whole process and procedure. So that's the difference between the two questions. All right. So with that, I'm going to stop sharing and hand it over to Florence to introduce 2933.
Okay, Dynamite, can you hear me?
Yes, I can hear you.
Wonderful. So I'm going to plan to share my screen.
And as soon as you do, I will end the poll. There
Okay.
you go.
Can you see my slides?
Yes.
Excellent. Well, Maria, first of all, I want to thank you for your leadership and teamwork on this from the beginning. Maria and I started working on this a number of years ago. I think it was maybe the beginning of 2018 at a meeting in Orlando, Florida. And ever since then, we've been going and growing. And it was really a great start because we're going to talk about leveraging this TIPPSS framework: trust, identity, privacy, protection, safety, and security, beginning with clinical Internet of Things, going deeper into decentralized clinical trials and remote patient monitoring, and then going across multiple industries, or cyber physical systems, as some people call them. So I'm executive director for the Northeast Big Data Innovation Hub at Columbia University, funded by the National Science Foundation, the National Institutes of Health, and the Department of Transportation, which we're very grateful for. And I'm delighted to be chair of the IEEE 2933 Standard Working Group for this space on clinical IoT data and device interoperability with TIPPSS, and very grateful for the 250 members around the planet that helped us create it and get it approved. So a little background, this is something you probably all know, but just to frame it, as we know, advanced technologies can enable digital transformation in so many ways. There is more accessibility to information, more accessibility to the devices, more interoperability, more insights you can gain, leveraging the Internet of Things or blockchain technology, machine learning, big data, augmented reality, artificial intelligence, all these wonderful opportunities. But they can also all increase risk. So when we look at the connected healthcare world, how we want to leverage advanced technologies to improve insights and outcomes and get to precision medicine, precision oncology, precision healthcare, where you're leveraging real information about the human, research results that actually pertain to them, environmental information, connected healthcare devices and data, the actual clinical care data from working with your provider, environmental patient lifestyle data, and clinical and fundamental research. All this cool data creates a compendium of healthcare information that can be leveraged to better serve you, serve the humans. But more devices and data can create more security and privacy attack vectors and risk. This is a quote from Dr. Suzanne Schwartz at the US FDA Center for Devices of Radiological Health. Any medical device connected to a communications network like Wi-Fi, the 802.11 Maria was mentioning, or public or home internet may have cybersecurity vulnerabilities that could be exploited by unauthorized users. And as a matter of fact, over the years, there have been a number of recalls by the FDA because this increased connectivity does increase the risk. And as they say, what could possibly go wrong? Well, a lot could go wrong. And that's why we're building standards in this space. So way back as far as 2008, the FDA identified software vulnerabilities that could let hackers take advantage of personal medical devices. In 2017, they recalled 465,000 pacemakers due to cyber hacking fears, where hackers could reprogram 20 types of devices with adjacent access, low skill level, and like within 50 feet of you. So as I say, well, if you're sitting in a movie theater, or if you're walking through a mall or wherever you are, how many people do you trust that are within 50 feet of you? How do you know? And then in 2018, a voluntary recall on certain insulin pumps, implantable cardiac devices, and then another recall in 2019, and the list continues. And these are not like cute little companies that are doing this for the first time. These are vendors you know and trust. So this is an issue we need to deal with across all of our technologies. So what we need to do is secure the connected healthcare devices and data while enabling interoperability, because we want to be able to use this information, right? If you're in a different place and you're not near your healthcare provider and somebody is giving you emergency services and there's information they could get from your device and want to see what your normal baseline is, it would be wonderful if they knew, right? So the top concerns we have are connected healthcare devices and data, because if you hack one of those, you could immediately kill a human. Next, connected hospitals, campuses, cities, and vehicles, because if you hack those, you could quickly kill a human. So we're trying to keep the humans safe. And then clinical, scientific, and research device and data integrity. If the research data is hacked and changed, then decisions could be made that are not appropriate because they're not using real data. So we need protection at the device, hardware, software, and service level to protect against physical health and safety harm, financial risk for the companies involved, reputational harm the same way, data theft, integrity, or loss of privacy. And we need a defense in depth strategy at the hardware, firmware, software, and service level, and then need to evolve our policy and culture to expect this. So I've been talking about this for a while, as you could see, in 2015 when I was a VP at IBM. And I was developing the first Internet of Things strategies there, working with them and ARM and others. I know they're going to hack everything, so we have to get ahead of this and stay ahead of it. So what we did is started creating, actually, I was on the Cisco IoT World Forum Steering Committee, and at one of the meetings, another gentleman involved with IEEE and I were talking about how nobody's worrying about end-to-end trust and security. Everybody worries about their own little space, their software, their device, their EMR, whatever, but it's all connected. So what we said is, so no one's worrying about it, why don't we worry about it? So we created this initial thought of TIPPSS, trust, identity, privacy, protection, safety, and security. And then we hosted a workshop with IEEE and National Science Foundation and then DoD and a bunch of organizations. So as you look at this, trust is allowing only designated people or services to have device or data access. Identity is validating the identity of the people, services, or things to make sure you can trust them, and then having that do loop in your technology. Privacy is ensuring device, person, and sensitive data is kept private. Protection is protecting the devices and users from harm. Safety for the devices, infrastructure, and people, and then maintaining security of data, devices, and people, which is really cybersecurity. So when we first got involved in this, we started this little pre-standards work stream under the Industry Connections program that Maria was talking about. And we created this, I call this high level, but I used to do finite element modeling as an aerospace engineer. So this is high level because all the details are in underneath it. But we created this, this TIPPSS framework for clinical IoT data and device interoperability starting in 2018 and then published this in 2019. And what this shows is everything we have to worry about. So at the user experience, user interface level at the top for patients, providers, payers, the devices have an interface, pharma, research, applications, integration layer. As we say, the beauty of standards is there are so many of them. So in healthcare, FHIR, HL7, SNOMED, ISO 11073, a number of these, any application programming interfaces or software development kits, and then distributed ledger, connection, data ingest and management, and all the devices and data. And across the top and bottom, you can see the green on the right. These are all the things that go across everything that are really part of the TIPPSS framework: security, encryption, federated identity management, all the way to governance. So we started with this, and then we launched the TIPPSS working group, Clinical IoT Data and Device Interoperability with TIPPSS in 2019. For P2933, it's a project with a P before it's a standard, which we just graduated to. And it's the purpose was to establish the framework with TIPPSS principles: trust, identity, privacy protection, safety, and security for clinical Internet of Things, data and device validation interoperability. This includes wearable clinical IoT, implantables, and interoperability with healthcare systems, including EHR, EMR, other clinical IoT devices, in-hospital devices, and future devices in connected healthcare systems. And you say, how could that be? Well, we have to work with what we have today, but we know some of the technologies that are coming out. A number of us are in the advanced technology space. And the point is to make sure it's an extensible framework. So we created this working group. When you first create a working group in IEEE, they ask you how many people will participate. And I said, well, if I invite my best friends, maybe 25. So now we have 250. So it's interesting because when you talk about this need for, tips for clinical IoT devices, people who know look at you with like laser beam eyes and say, I'm glad somebody's doing this, I'm in. So I'm the chair at Columbia University. I have my executive director role, so that's my main institution. I also have a consulting business, FD Hint, which is Lawrence D. Hudson International. Our co-vice chairs are from Medtronic, William Harding, so a device manufacturer in this space. And then Mitch Parker at Indiana University Health, who's the Chief Information Security Officer. So the manufacturers and the deployers, both ends of the spectrum. And then our secretary for the working group is Ken Fuchs from Draeger Medical Systems. So once again, all the way in. And actually he leads the 1107D3 working group. So we have all these humans across 22 countries, including technologists, device manufacturers, providers, payers, NIH, IEEE, underwriters, laboratories. And we created, how do you get 250 people to work on something together that has so many pieces? Create a little subgroups. So we had trust and identity, privacy, protection and safety, security, data and device validation, interoperability, integrated systems design. Remember, it's all a system of systems, all connected together, including AI and ML. We decided not to put artificial intelligence and machine learning into the base standard because there's so much going on with that right now. There are actually over 50 IEEE working groups working on AI standards right now. We're like, let's see how this plays out, and then we can, refer to them. And then use cases and scenarios, including human factors. So how do we make this real? So I wanted to share a little something when we had our, from the standard, the draft standard, when we had our little prep call the other day, we were talking about people, organizations, and devices. So we have this little thing we call tripod in the standard. It's in the current draft, and I'm just sharing it with you for an idea. And what we did is we came up with a few use cases: hospital at home, home to hospital, an insulin delivery system, a continuous glucose monitor, things people could identify with. And we look at these different aspects of it, the medical device manufacturer, the hospital, the humans, people at home, and we have all these different elements and then go into technical details on each one. So I told you about how we got here. This is the life cycle standard from IEEE. You initiate the project, which we told you we did. Then we get to mobilizing the working group, drafting and validating the standard, gaining final approval. We got through that one. Now maintaining, but also where do we go from here? So let's plan more tips. And so that's why this webinar series is called, Cybersecurity Tips for Industry. So we're hosting together, Maria and I, IEEE and the Northeast Big Data Hub, this workshop series. We'd like to kick off a Tips for Decentralized Clinical Trials effort, which we're hoping some of you want to participate in. Some of you might even want to co-lead it or lead it. And then we're expanding to tips for other cyber physical systems, precision agriculture, connected vehicles, and energy grid, if people want to take that journey with us. Here's a sample poster that Maria and I guess created with some other people that she shows. She's shown in a number of locations, including to some people at the FDA, I believe, that looks at what would a technical standard scope be for decentralized clinical trials as a care option leveraged with hospitals at home. This is the framework we briefly reviewed. This is a little bit about it. I think these slides will be made available. And then here's the use case, hospital at home, remote participant monitoring. And these are the details we can get into in the discussion later. We like to have a user view and a technical view. So what does the human see, and what do the geeks worry about in the back end? And you could be one or both. And there are also some publications if you want to read about tips. There are some articles, Security in the IoT Ecosystem. I mentioned that briefly with the 2015 quote from me when I was still an IBM. Another one in smart cities, creating, analyzing, and sustaining smarter cities. And there's a tips chapter in there, as well as a couple of IEEE articles, enabling trust and security, tips for IoT, wearables and medical interoperability, the evolving frontier, and we have a couple of Springer books as well. So that's what I wanted to share with you today.
Sorry, Florence, I think you're on mute. We lost you a little bit there for a second.
Ooh, when did you lose me?
Yeah, right at the end, after you introduced the books, at the end of that.
It's probably because I stopped sharing. I'm sorry. And
no worries, no worries.
Presenter.
Yep.
Okay.
All right, well, that was perfect. So for everybody out there, obviously, I shared with you all as your quote unquote homework, but we don't call it homework, in preparation for the brainstorming session, all the registrants as of yesterday should have received the copy of the poster, the PDF, which Florence shared with you all, which is the premise of the brainstorming session. Just FYI, that was developed in collaboration with the Clinical Trial Technology Modernization Network program. So they're focused on decentralized clinical trials, that particular program. And so we collaborated with them to present this poster. But do know that the use case requirements for the clinical trials part is very preliminary, and that is where obviously we're going to get into a little bit later in the brainstorming session. It is not a final product. All right. So with that, I'd like to bring Gilles to talk about real world scenario of using the IoTs in a multi-country decentralized clinical trials and other applications.
Thank you, Maria. So let me share my screen. You can see my screen?
Yes, if you could just put it in presentation mode.
Perfect.
There you go.
Indeed, the company I represent, MediSanté, has a firm belief that to enable these remote patient monitoring, hospital at home, initiatives, decentralized clinical trials. If you want really to inspire trust on the doctor's side, you need to bring the cellular connectivity to the home instead of just relying on the smartphone of the patient, the consumer smartphone of the patient. And we believe that doing this is the only way to keep the device experience seamless and secure in decentralized clinical trial. And here already there is an element of balancing the seamless, the ease of use, and the security, because obviously if something is super secure but nobody can use it, it's difficult to scale those initiatives. And vice versa, you know, if something is super simple but lacks total security, I mean, there are other problems that prevent scalability. I was at the end of my slide. Apologies for that. So first of all, COVID was for us a trigger, because everybody realized that the people most at risk were not, they could not be telemonitored. The data from all those IoT devices out there, consumer devices, they could not, the data did not reach the screen of the teledoctors, let's say. It was a lot about individual one-off consultations, but really the, let's say, the automated collection of vital signs, this really didn't happen at scale, and still in most parts of the world is not yet available. And we believe that to make this happen, there needs to be a paradigm shift in the device experience to meet the needs of what is really required in virtual care. And while you know, we often think, when we think of IoT, of consumer gadgets, consumer devices, and we think of the person on the left who is very digital savvy. Very often the people, for instance, that need to be included in clinical trials or in remote patient monitoring, they are maybe more on the right side of the chart at the top, which means that you know, either they are elderly people or they are not digital savvy, etc. And we believe that one of the key elements why basically the data could not be collected from all those amazing consumer devices is that probably the medtech software silos, the mobile app, the proprietary cloud, the proprietary API of each medtech vendor who has devices at home, they all rely on consumer smartphones. And these different stacks of software of all the medtech vendors, at the end, they stood in the way. And that's why we really believe that in the future, to scale decentralized clinical trials, to scale remote patient monitoring and automate the collection of data from IoT devices, there is a need for cloud infrastructure where the devices are provisioned. And this is important in terms of the trust of TIPPSS, because if you want to collect, let's say, IoT data from 10,000 blood pressure monitors, usually the cardiologist in the team will probably want to check the accuracy of the blood pressure monitor that the clinical trial team will buy. And so I'm really here very much coming from the side of the doctors choose the devices, they buy them hundreds or thousands of times. And what is very important is that the patients can just be included in the trial without any need of being technically savvy or having technical infrastructure in the home, having broadband access, having a smartphone on their own, etc. So it's really to have no configuration by the patients in the home. And so basically, with this in mind, what do I mean with keep the device experience seamless and secure at scale? And I believe it's a multi-dimensional topic. And Florence alluded to it before. She mentioned the users, the end users, the geeks, and of course, everybody has a different lens to look at the same problem. And I believe that there is a first layer, which is directly the device experience of the patient and of the doctor. So if it's a clinical trial with provisioned devices, the device needs to be assigned to a patient, and often trials have hundreds or thousands of patients enrolled. So these, in terms of device experience, this device assignment, today there are two choices. Either it's in the consumer space, the personal identifiable information, gets entered by the patient directly in a mobile app from the device vendor. But if you talk about clinical trials or remote patient monitoring with provisioned devices, then usually the doctors want to keep the ownership of the protection of the personally identifiable information and leave them in a compliant health IT system. And that's where the device assignment to a patient happens. Device 33 assigned to Mrs. Jones, go home. Then on the patient side, of course, in the consumer space is a consumer smartphone, which is a cellular gateway to send the data. But in the B2B space with remote patient monitoring or decentralized clinical trial, usually, as I said at the beginning, we believe that it's about bringing the cellular connectivity in the medical kit. And this avoids any need to configure the device with a smartphone because it's often not that easy, even for digital savvy people. You probably all struggled with configuring some device via smartphone, via Bluetooth. So this first layer is really the device experience of the patient and the doctor. And there is a change happening from the consumer space to the more B2B telemetry type of space. Then the geeks that Florence mentioned, first of all, to get IoT data into a health IT system, into a clinical trial management system, remote patient monitoring platform. If you want to, if you use consumer devices, you will have basically to go to APIs, pull APIs of multiple medtech device clouds. So they all operate in silo, all have a different API, etc. And we believe that in the future, there is a need to have an integrated telehealth cloud that where the data is pushed in near real time instead of just pulled every 3 or 2 hours or 5 hours, etc. And of course, when you talk about device management, in the consumer space, you don't need to manage devices. You just have your own device, your smartphone, and that's it. But if you enroll patients in clinical trial, you cannot conduct a clinical trial without managing devices. It's a must-have both in remote patient monitoring and decentralized clinical trials. So this is really the technical support team layer, the second layer of the rocket of the device experience. And the last, but not the least dimension is the whole B2B purchasing and logistic experience. So the purchasers, I mean, how because it's not the consumer who goes in the supermarket into Walmart and buys the device. It's maybe a practice that orders via an e-shop devices from its clinical team, who then basically make sure that there is a whole workflow behind it that triggers a logistic, bulk shipment, drop shipment to replenish the required devices. And this last part is just a reminder that unlike a lot of digital technologies, devices cannot yet beamed virtually to their users. There is logistics involved, and this is often a big issue to scale digital health. So how did we go at MediSanté about making this device experience both seamless and secure to enable the scale of those programs is really about offering choice of devices that connect directly over a cellular network out of the box, and to do that in 3 ways. Because depending on the use case, there are different needs. Sometimes there is just a need for a cellular IoT medical device, let's say a blood pressure monitor, with a direct-to-cloud connectivity. But sometimes there is also a need for multi-morbid patients to have a cellular IoT gateway. And then there are two options, either no user interface, just a box you plug into the power socket, and you can auto-pair, or the logistics companies prepare the Bluetooth devices so that the patient truly has this experience of no configuration. And the second option is really to rely on a smartphone, or a tablet, so Android with mobile device management, similar, no configuration by the patient. And basically, our view is that the platform we have created to which such devices from multiple manufacturers connect in multiple ways. We say that those devices, which are not ours, we say they are powered by MediSanté. It's IoT powered by MediSanté. And so once those devices with a lot of engineering, or the gateways, have been integrated basically into our platform, then from there we can integrate them into third-party health IT systems. It can be clinical trial management system. It can be remote patient monitoring platforms. It can be anywhere in the world. And on top of that, we manage the devices across the different devices from the multiple manufacturers. And what is really important is that we wanted to leverage global technologies. And this is possible with our platform because there is no personally identifiable information of patients in the way we have gone about integrating those devices. And so basically, coming up with a platform, that keeps this device experience seamless and secure, it's I would say a three-step process at a logical level. First, it's about standardizing devices that are all different. There is not a single manufacturer that would build the device and the APIs and the interfaces, the output of those devices the same way. So it's about standardizing the output of those devices by seeing them as a kind of SIM card in a device or a gateway with a housing around it, and that measures something medically meaningful, of course. So this whole engineering work, we have now been doing it for a significant number of devices, but this range is growing. Then the second aspect is once you have standardized, you can abstract those devices as a digital connectivity twin, and you can do so across multiple vendors and multiple countries. And you can easily integrate with one point of integration this platform to the target system, which are the clinical system. We do that in 3 clicks. We enable the health IT engineers of the target clinical system to create their own output adapter. It's a 3-click process. And we enable them also to manage the device fleet with the status of the telecom arrangements, because there is a SIM card in either the gateway or the device. And once this standardization and this abstraction in the cloud is done, then of course, the ultimate goal is to deliver medical IoT data as a service instead of as a nightmare to the care teams in the platform they have chosen. And we know in healthcare, it's not like in automotive, where Germany, there are 3 manufacturers, we know them. If you look at healthcare, there are hundreds of software vendors who offer clinical systems that have their legitimacy, their capabilities. And what we want is really to deliver that data with no compromise on privacy, because the device assignment always happens in a compliant system. It starts on the doctor's side. Then in terms of security, we don't want to make compromise, because the whole data in transit from the device to the clinical platform, it's encrypted end to end, and there is no patient identifiable information that we can get. And of course, by keeping it also seamless, it allows inclusion. And this balance of privacy security based on the trust the doctors have in the device allows then also inclusion. And so, I think that the ultimate goal of delivering IoT data as a service to the care teams in the platform they choose for whatever reason they choose them, it's really to scale globally clinical trials, decentralized clinical trials, remote patient monitoring. And so what we've learned over the years that there is an abstraction layer we have created, which is all about IoT, cellular IoT, SIM cards, cellular IoT modules, the cloud that abstracts those SIM cards. But there is still the real world of the devices of the manufacturers that are attached to that digital connectivity twin. And we have decided to work to start with 3 main manufacturers who represent about $750 million of revenue, and help us now to basically connect a lot of their devices either via gateways with UI, without UI, or directly cellular devices to our platform to offer a broad choice of such a device that connect out of the box, can be easily integrated and managed across the different vendors by telehealth platform or decentralized clinical trial platforms. And what we've learned is that the software providers on the clinical side often underestimate, that the physical world needs to be handled. And but it's a very big value, because we work very closely with our manufacturers to make that that bottom of the layers I showed you on the previous slide, to make that a smooth experience as well, that the logistics, the bulk shipment, the drop shipment that is required all goes smoothly and often in different geos. So we got some awards, some partner endorsement. I think I'm not here to talk too much about that, but I want to mention now some real examples. For instance, with George Medicines. So George Medicine is a biotech that implemented exactly that philosophy of leveraging an IoT platform void of personally identifiable information from patients. And they deployed for a global phase 3 decentralized clinical trial. They started during the pandemic. The trial lasted 3 years. It was about a 3-in-1 pill combination against hypertension. And a key requirement was that they wanted to be able to involve subjects from across the world. So the trial has been deployed across 5 continents, initially 4 continents. Africa was not part of the trial at the beginning, but at the end, they also included Africa with Nigeria. And so basically in this trial, they really wanted to be inclusive, because the patients who suffer from hypertension, you don't choose what education they have, what infrastructure they have in their home, are they digital savvy, or they not digital savvy. All these, with the illness, you don't get asked if what your social determinants of health are, right? You just have the illness. And if you want to include everybody across the world, then there should be no obstacle in the inclusion of these patients. And this is what George Medicines wanted. This is what we delivered to them with the vision I outlined previously, with an IoT platform that allowed them to basically push the data to their clinical trial system, which happened to be from IBM, but for us, it's just a target system for which our clients create an output adapter. And they leveraged a global cellular blood pressure monitor, which was a 4G blood pressure monitor with 2 versions of it. A version with an IoT module that was working specifically in a Cat1 module in the USA, in Americas, and another one for the rest of the world. So basically, we deployed 2,500 such cellular IoT devices and helped them collect about 700,000 readings from trial subjects with a very specific detailed protocol. They have now submitted their FDA approval. They are a spin-off, maybe I haven't said that at the beginning, of a famous research institute in Australia called the George Institute for Global Health. And it was a very a rewarding experience to support basically the sponsor, George Medicine, but also the investigators. For instance, in the UK, we had the clinical trial business unit of Imperial College that was the investigator. So this is really a real life experience that we had over 3 years to support George Medicine, and now we're crossing fingers. We hope that they get the FDA approval, but of course, this is a totally different discussion and topic. We just contributed as an enabler to the seamless and secure IoT data collection at scale for their trial. And we learn a lot, of course, from those customers, the requirements they have. And another thing I want to mention, we are involved in a consortium which has been newly created in Europe. It's called CIMEDSEC, and it's all about cybersecurity of connected medical devices, and all about the regulatory aspects and basically how to assess the risk. And while probably 90% or 99% of the devices that are connected today really in a clinical trial environment, in a hospital environment, they are in the hospital. Now with this Internet of Medical Things, with the pandemic behind us, really the new generation of risk is when the devices are in the home, and there we believe, of course, that bringing cellular IoT connectivity on a private cellular network is in a different league in terms of security than relying on an unprotected device with a smartphone of the consumer. But anyway, in this, so Europe takes this very seriously. I'm based in Europe, and so it's a 4-year project where it's led by Technical University of Dresden, Professor Steven Gilbert. And in this project, EU-funded project, we lead a work package which is about cyber secure IoT fleet management to enable the hospital at home. And so I just want to share with you this thinking about how I believe we can keep the device experience seamless and secure at scale in clinical trials and in remote patient monitoring, to scale those initiatives more and more. And basically the real life example with George Medicine, and something more forward looking on the research side with CIMEDSEC. Thanks for your attention. And I understand that the questions are at the end, right, Maria?
Yes. So thank you, Gilles. So now I'd like Ryan, if you can present, and then at the end of Ryan's presentation, I'll share the poll results, and we'll also go through the questions. We already received some great questions from the audience, and we'll try to get to most of those questions. All right.
Okay, can you hear me?
Yes, and we can see your slides.
Okay, good. All right. Envelope is currently doing a remote patient monitoring where we are looking at ways of an ultrasound technologist being self-employed, going to a house and giving an image of a tokenized radiology image using 5G IoT. This allows a self-employed U.S. technologist or administrator to distribute a copy to remote patient monitor subject at the patient at the time of service. Our history started with decentralized physical infrastructure. So we originally started by outfitting houses for IoT automation and quickly kind of saw the use case for all-around package inclusive for remote patient monitoring to include radiology monitoring. 5G is very good for that. Through the use of our history started with DPIN telco, decentralized physical infrastructure, and through the use of this own IoT 5G portals that we have for patients through Helium, they can easily pay for transmission of data by using IoT or mobile tokens. The idea is to be cost zero for the patient to do their oh, hold on here. Oh, can you still see?
We don't see your slides right now, Ryan.
Okay, hold on. For some reason I wouldn't. Okay. Now can you see?
Yes, they're back.
Okay. So Helium is an IoT blockchain network that grew naturally through the incentive of tokenomics. They were able to build a global network of entrepreneurs that relayed IoT and 5G data through payment of IoT and mobile tokens to the users. So they were able to grow this almost international network of IoT devices just by providing, by selling a IoT relayer that would continue on a LoRaWAN IoT signal. And that eventually grew into a 5G network. So these are actually customer nodes for Helium, but they are actually patient nodes that are actually a way for them to use the Helium 5G IoT data credits. And one data credit is quite inexpensive, and you can transfer 1 gigabyte of data for 50 cents, which is rather advantageous for blockchain uses. So this, if you notice, is the tip screen. And I'm not going to go through every single thing here, but basically, as stated, Helium is an IoT blockchain, meaning for the tips, the trustless information means we use decentralized identities or P275 over encrypted keyed blockchains. It's a standard SHA-256 encryption that ensures Helium's proof of coverage, which allows patients to own their own portal and to create an income with mobile tokens at the same time. The proof of coverage consensus allows the networks to stay running at all time. Helium does have an explorer where you can go in and find these devices if you're familiar with blockchains, but does not reveal addresses or names. In fact, you can only confirm if it's in a cell or a device is from the outside if you wouldn't know, and you wouldn't know its actual application. So through the blockchain network of decentralized identities on both ends, we are able to share an IoT stream in either the 600 to 680 range and the LoRaWAN range, and all contribute them into a one working stream, data stream to go through a telemetry device, which would be that IoT portal. Now, within this whole economy of the Helium, tens of manufacturers have popped up that will create any device you want from scratch to be used on an IoT blockchain. There are indoor, outdoor environmental stations that can react and augment findings from clinical IoT devices. These manufacturers also work with clinical IoT devices like medicine dispensaries, panic alarms, flood warnings. And not only can we monitor the human, we can monitor the house all through an IoT accelerator like a Helium patient portal. So what you have through this whole ecosystem of Helium are people who actually who have started their own entrepreneurial businesses where they go in and they automate a whole house for you. They're able to put it on an IoT or a 5G blockchain and relay that information in a decentralized identity through a decentralized identity to another decentralized identity, which can be a hospital or a practice, a service, an individual doctor, if you will. In addition, there are other decentralized physical infrastructure networks for power grid building that we recommend for people to use as remote patient monitoring power backup, where people actually get paid to collect power and to share what power they don't use. So they are able to consume power, have their own environmental devices, and have their clinical IoT devices to all automate their house in states of emergency, power outages, all sorts of inclement weather that you can think of is the point of that. So when we move on to exactly how DPIN in healthcare we apply it, and healthcare services are naturally decentralized. What we've seen is the hospital ecosystem just explode. So on every corner, we're seeing diagnostic imaging centers, we're seeing ambulatory surgery centers, we're seeing blood labs, we're seeing all these different places, and all of these assets that people need to put together are really hard to do so. But in healthcare, if you put them in a decentralized physical infrastructure network, you can create a society of democratic businesses that vote on their own industrial standards, including P2933, to easily communicate up and down the DPIN. So we use P2933, P2975, and ISO TC 307 and others to combine and create an efficient system of sharing information and moving up and down the DPIN. They're designed to create standards between dissonant facilities by adhering to improvement protocols proposed by members of the DPIN. So normally we have what would be a nonprofit STEM in the middle that would find and do some of the same things as IEEE, but of course not to the same degree, but would come to the same standards and would see something like P2933 come through, probably already adhere to it, but say, those are the standards that we're going to adhere to now for ethical construction of what we consider to become more of a patient dashboard that includes their IoT breakouts and their IoT readings. And what that basically means when you have all these dissonant facilities put together, all the decentralized parts of medicine work as one to offset costs and create a larger business model. And this is how the IoT DPIN grew and why there are so many suppliers, entrepreneurs, and people who probably did not even know what IoT was when they bought the machines, just to get the tokens from it that at the height sold for $46 just for transferring IoT data. And a lot of these people didn't even know what it was for, but it goes to show you the actual network capabilities and the natural growth that tokenization can have to promote remote patient monitoring. And we don't actually even see remote patient monitoring as being something of just chronic care. In the future, you might actually see these self-employed ultrasound technologists work from adaptive healthcare studios in condo buildings, home care associations. As the devices get smaller and smaller and smaller, radiology, ultrasound, and eventually smaller and smaller MRI and CT machines in the way future will allow for these things to be either in strip malls and adaptive spaces changed out all the time. And so you have the idea that you can decrease the cost for a patient to transport themselves back and forth to a hospital even by choice, if it's not just chronic care. So with Envelope, we create human artifacts and IoT parametrics as NFTs for people to create their own library, to start to be able to confirm participatory, personalized, and possible dispositions. And this is where our ethical AI starts through P2795, P2933, ISO TC 307, and some other ITU, and of course, NIST guidelines for IoT. Those are then assembled by a decentralized identity to put together, add their own, like a radiology file, an IoT data sheet, or data screen. Oop, went one, two more. I don't know what, okay, we're fast forwarding here. Sorry about that. Oh, whoa, there we are. Okay. So this allows, if you have all these readouts, including the IoT readouts, it allows the patient to assemble and submit a proof of need of service to their PCP. And what ends up becoming is a distributed service level agreement for the PCP or AI to submit for approval from insurance. Now, when you get an up to the minute report of everything that's happening, of all of their ancillary NFTs and an AIoT NFT with the P2933 IoT Oracle, you have proof of quality outcomes that should be greater than 3 for a appended advanced radiology technology report, which can be sent to their doctor where they can approve this, say these findings are fine, they're not fine, and in our model, you go on to an organized DPIN, where ancillary 2.0 creates new values and new assets. And we have an envelope constructory where you make your own digital, or I'm sorry, distributed service level agreements so that your doctor can have an actual screen data sheet right in front of them of all of your ancillary, including up to the minute IoT readings from your house, from your own device. And this allows for people to, in their own right, if need be, do what is called a blockchain proof of need of next level of service by constructing their own blockchain proof. And therein lies the magic of Envelope. So with that, I will stop sharing, and hopefully that made sense to everybody. Did I stop sharing?
Yes.
And it is a very high level kind of what it basically is we're just trying to put together as many ancillary assets as we can, including up to the minute bio IoT readings that can show for an advanced up to the minute report and proof of need of next level service. And P2933 is a great standard to comply to for our DPIN in that fashion. And I hope that made sense to everybody. Florence, I actually ended up having COVID, so I do have a little bit of that COVID brain. But hopefully we got the picture across there. So
I'm sorry. I hope you didn't catch it over Zoom the other day.
That would be scary.
I
Okay.
said that too. So we have 2 COVIDers on here, so be patient.
yeah.
So first of all, thank you, panelists, for a really great presentation. I think we tried to present a very diversified sort of approach here. Obviously, looking at first the standard that's currently in publishing, a real world use case, and obviously the forefront of new technologies and new ways of thinking of data and using sensors, and obviously in the world of clinical research. So I know we had some great questions. I know Florence had a couple great questions for the panelists. Perhaps Florence, did you want to go first? And I know you had a couple good questions.
Yeah, well, can you hear me okay? My
Yes,
voice.
yes, no problem.
So first, we invited Ken Fuchs to join as a panelist. He is the secretary of the working group, but more importantly, he's a standards expert and runs leads the 11073 working group. So what we thought we would do is try to answer a couple of the questions in the Q&A, and then I can ask some of my other questions. Is that okay?
Sure.
And hopefully Ken can be unmuted as well.
I think I'm unmuted.
We can hear you.
All right.
Excellent. Thank you, Ken. Thank you so much. Do you want to answer Patrick's first question, or do you want me to rasp my way through it?
Let's see. Patrick, I think had a
What actual industry standards and
right.
ISO 27000 NIST 800-53 Rev 5 did you base your standards on?
Yes. In terms of normative references, now normative references are references that are kind of rolled into the standard. So you need to, if you want to say you conform with the standard, you also need to conform with the normative references. And we only have two, and those were 2701 and 2702, ISO IEC 2701 and 2702. I'm not the expert on the security side of things, so but those were definitely key standards that were that need to be part of the standard, and not and the requirements of those standards are not necessarily included in 2933, because that would be duplicative. In addition, there are a number of other standards that are in the bibliography, so were either referenced in the standard or used as reference material in preparing the standard, and a number of NIST 800 series standards were included, including, I can read them off, 800-130, 800-131, 1800-16, 800-193, 800-207, 800-53-5, 800-63-3, and 800-88. So those were the NIST standards that were, I guess, part of the knowledge base when we created the 2933. There's some other standards also. There's probably about 20 other standards that are similarly used, including standards such as 14971, which is a standard for a medical device risk management. So that's definitely a core standard when you're doing medical devices and doing risk management for medical devices. But there's some others as well.
Thank you so much, Ken. Ken is our standards everything expert, and very involved in AMI and ISO and other things. So, and Patrick or Mark or others, if you'd like to join the working group, you can, even though they approved 2933-2024. The opportunity now is to look at how we're going to implement this in these different spaces. And as an example, Mark, also when you ask questions about, or Patrick, I guess here in, FedRAMP, which is very US, HIPAA, which is very US, and this is a global standard. Actually, the privacy leader for the privacy parts of the standard was in the EU before Brexit. Now she's just in the UK, but was leading it from that perspective. But we look at all the global standards to a certain level and say you have to, abide by your jurisdictional standards. So you're welcome to join the working group until the standard is officially published, which means, it was approved on June 6th, but now they go through the editing process. When it's officially published, everyone can buy a copy of it. But if you're a member of the working group, you can see the draft that Ken is reading from, and I could read from as well. And so you could jump into it if you'd like. We really welcome that, because for this to be deployed, we have to make sure it's connecting to everybody's cylinders and, synapses and plans and processes. So, please feel free to send an email to one of us, or you can go to P2933, the website, and it says, it has our email addresses. You can email me or Ken, and then we can get you added. So thank you for caring so much and all these great questions.
By the way, you can purchase a draft if you want to. I'm just looking at the IEEE SA Standard store, and it's available for $182, or if you're a member, $146, so you get a discount. But you know, if you can wait, or if you want to join the working group, then you can get it for much less.
Yeah. We're gonna twice the price. Okay, great. Okay, wonderful. So thanks for the good presentations. I thought they were great personally. Great job, Jules and Ryan, and Maria. Based on their experience, how do they assess scalability over security and IoT applied in healthcare? That's interesting. Jules, that might be an interesting question for you because you have a quite scalable platform. So this is a question from the Gabo Desire. Based on our experience, how do we assess scalability over security in IoT applied in healthcare? Do you have a comment on that?
Yes, I mean, the scalability comes from how easy it is for all stakeholders to be involved in basically the process, either on the medical side as a doctor in a compliant platform that typically in the US would be HIPAA. What's this device experience? You know, if it's seamless, then from a doctor's perspective, he can assign a lot of patients without going on strike because it's cumbersome, you know. So the seamlessness of the device experience is the baseline for the scalability. But of course, if it's seamless and as I said, it's not secure, it will never scale because before you scale, you run into a security incident and then your project gets stopped by the chief security officer. So it's all about how the device experience, and it's not only the patient, because normally you think, the device is cool, you know, it's no, everybody needs to be involved. For instance, if to integrate the device via there is always a cloud, right, between the device, the IoT device and the clinical system. If the API is cumbersome for the health IT engineers because it's weird, it's not polished, it's too complicated, then, you know, the guys will say, well, you know, it's not the type of device I want to integrate. Interoperability is a nightmare, etc. So, you know, the scalability comes from the device experience from all the stakeholders. And then security is a must, you know. You cannot, it's impossible just to say, I want to scale a system that is not secure, right?
Absolutely. Okay, great. I'm not sharing my screen, am I? I'm having a little Zoom problem here.
No, you're not sharing your screen right now.
Okay, great. So thank you, Jules. That was very helpful. So you don't decide on scalability or security. You have to decide on both. And so another comment on that, and that was excellent, Jules and Ryan, what you're presenting, and thank you for including 2933. I think you're both great examples of how to implement this and to get started on that path. The other question people sometimes ask us is, so why do you have safety and security and all these different things? When we created this originally, and I have to thank Oleg Lobvinov, he was very involved in IEEE IoT at the time, and we started all this thinking together. We were both on the Cisco IoT World Forum Steering Committee. And we said, you know, this has to be a global platform. I in particular speak, you know, a little Spanish. So I know like seguridad means safety and security. And safety and cybersecurity are two totally different things. So what we've tried to do is make this as global and accessible and explainable as possible. So that's one of the reasons you see like these multiple TIPPSS words. It's meant to be very comprehensive. I also want to mention for anyone who wants to join the P2933 working group, you can go to this website and then follow the directions there. My email is there, Ken's email is there. And so you don't have to memorize our email or you didn't copy it. You just have to say IEEE P2933 and the Google gods or Safari gods, whoever you work with, will take you there.
Yep.
And so Malham, you can go to that website. Is that okay?
Awesome.
That would be great. Another question, do we want to go into the brainstorming now as compared to more questions, Maria? What do you think?
Yes, we can start it. I just want to first share the results of the polls that we took earlier to, let me see if I can share them with everybody. I don't know if hopefully everybody can see them. So I think interestingly, well, maybe not interestingly. So we asked the two questions, right, in different ways about in evaluating which wearables sensors you're going to use in your clinical research project. And the criteria, it seems like the most critical is the interoperability with the current systems. And I imagine, obviously, we all know interoperability is a challenge everywhere in the healthcare domain, but that was interesting as well. What I found a little bit interesting was that what technical standards are being adopted in the development of the device was not one of the critical areas of that. And I think partially it's because I think when this is just my observation is talking with many different people, they're really not understanding what the technical standard is supposed to be doing. Like, why is it important, right? So Florence, I know, you tell me all the time, like my dream one day is for little kids to be asking about TIPPSS, like, is TIPPSS being used in my IoT device? So maybe you can just quickly comment on why things like this are so important.
Yes, thank you so much, Maria. Yes, so the story goes that, I'm a little geek. I was a rocket scientist. And so when I was a little girl, I would crawl around looking for the UL tag on electric cords because I knew it was safer. So the goal with this standard is to create it so that we geeks can implement it, the manufacturers, the solution providers, the integrators, the hospitals, everybody involved. But then we also teach the doctors, the nurses, and the patients and the payers as well at some point, so that in a few years when this is totally deployed and it might take a while to get it at a design-in level at chips and firmware levels. There are different elements to this. But more broadly, there'll be a little girl at the doctor with her grandmother, and the doctor is going to try to give one of them an insulin pump, and she's going to look up at the doctor and say, does it have TIPPSS? And that's our goal, is to make sure that humans know that this can make things safer for them. There's so much risk out there, and the more that they can help themselves, I think the better. And I think one of the reasons maybe we're saying that we don't really look at the technical standards adopted in the development of the device for TIPPSS elements is we haven't really had something this comprehensive. And I think for people to know the details that Patrick and Mark and these guys are asking is unusual. Normal humans don't know that. Normal patient. I mean, not that you're abnormal, but I mean, you're brilliant and really knowledgeable. Not everybody is that knowledgeable or knows how to become that knowledgeable or knows how to translate that information. So that's why we wanted to create this standard at the very detailed geek level, all the way up to then planning on, making this a marketing campaign for humans to ask about as well. And then hopefully that will go up, and maybe it'll actually become part of what they expect. That was the note on one of my slides about changing the culture, is creating expectation that this should be there. It's like you're going to have a seatbelt in your car. That's an expectation now. When I was younger, people were like rolling around in the back of a station wagon with puppies. There was nothing like that. And so these are ways that things can be safer. And so we hope that they're more understood and expected over time. So this is a great baseline, Marie, 3%. Ooh, when we do this in a year or two, hopefully it's a lot higher.
So excellent. So real quick, the second polling question, again, we saw interoperability as one of the main challenges, but as well as the security and privacy, which I think is a great segue into the brainstorming session. So I just want to share my slides real quick about this. Let's see, share. So the brainstorming session, let me see if I can just play from current slide. Okay. So let me stop sharing these polling results because we've got them. Okay, so here we have, I just want to real quick on the brainstorming session, everybody has and is invited and encouraged to share ideas. Okay, there's no wrong suggestion. There's nothing that's incorrect. If it's an outlier, just say something that we didn't think about or nobody else thought about it, we put it into a category, and we'll keep it there for consideration because most likely it will resurface again. So the idea is to build on the ideas of others. We're all exchanging ideas and it makes us think. We really need to state a topic because we have about 45 minutes and we're going to do pretty much 2 brainstorming boards. One is going to be on interoperability and one's going to be on security and privacy, which we all know already from the polling results are the 2 biggest areas of concerns. There's no judgments here. Like I said, if it's an outlier or wild idea, I think we encourage more of that. And think big, right? We're building use case requirements. We're trying to say, how do we take this 2933 architecture to secure all these sensors, IoTs, wearables that we are deploying in more remote monitoring of patients, you know, and also it's not just monitoring, right? We see in a lot of use cases, it's remote therapeutic delivery. So there's the same concerns of security and privacy and interoperability with those devices as well. And again, think out of the box, right? Let's not, I mean, obviously we all know we're in a regulatory compliant sort of industry, but as well as where can we really think, okay, you know what, this can really help us address these problems. So with that, just a refresher, I had sent you all this, if it lets me move my slides. Oops, sorry, too far. There we are. So as Florence showed you, as I emailed all of you, we're going to be focused on this 3rd column, we'll call it this way, for the proposed use case for remote participant monitoring, remote subject monitoring, ideally using this architecture framework that's in the 1st column here. And how do we bring it into for remote subject monitoring? We know there's nuances, right? So obviously with clinical research, obviously there's extra levels. We consider the IRBs. We also have to think about electronic data capture, right? We're thinking about the multiple partners here. You have the sponsors of the trial, the investigators, you know, the CROs, like there's a whole bunch of different players in this process. And so this all has to be accounted for in our use case requirements as well. So I'm going to stop sharing and let's see if we can get one of our boards up to start. Let's see, whiteboard. Let's see if I can get my whiteboard going here. New whiteboard. Okay, so let's see if I can start typing here. At least put the name of the first one is going to be interoperability. Let's see if it lets me type. So audience, I think you can either, if you want, type some ideas in the chat or, which might be the best way to do it, because if everybody's talking at the same time, we won't be able to get all of them going at that point. Let me see. Let me see if I can do a post-it note. There we go. Let me see if it lets me do it. All right, so this first one's going to be on interoperability. Okay. Which was our most popular one, or lack of interoperability is a big challenge that we see in devices. So, attendees, what are some of the things we have to think about when we think about interoperability in a remote subject monitoring scenario? Let's start with one. Let's see, interoperability here. Let me see if I can get this. So what about, I'm going to just try a different color here.
Maybe just a comment.
Yes.
You know, as we probably have a technical audience of engineers, you know, interested in IEEE, interoperability is typically a technical topic, right? If we had 1,000 doctors in the audience, you know, what do you think of the patient experience so that he doesn't call you for stupid things you don't want to be called for? Maybe this would have been the winner, right? So.
Absolutely. So, Gilles, right? So when we say interoperability, what exactly are we saying?
Well, so interoperability, it's at the end, when you talk about IoT, you always have a cloud somewhere. And if you talk about the clinical trial, you always have a compliant clinical platform somewhere. And so there needs to be a way to extract from the cloud of the device manufacturer the data to push it or pull it into the clinical trial system. And so the issue often people face is that they might need multiple types of sensors. And as there is not one single manufacturer that produces all the sensors the doctor or the clinical team, the investigator might need, they end up with interoperability of silos of software that all operate in a different way. And yeah, that's why, for instance, we try to aggregate, to act as an aggregator of multiple devices that all connect via cellular connectivity.
Perfect. Okay, good point. So I noticed one point here was interoperability with the EHR system. So are we talking about obviously going into a person's a potential subject's EHR record at a hospital system, or is it the EHR record that's being monitored and managed as part of the patient's participation in the trial? Because I think the former is going to be harder than the latter.
Yeah, I think it's related to the trial, right?
Mhm.
Usually.
Yep. So, oh, so he wrote in the hospital system. Okay. So with the point on interoperability with the EHR system in the cloud, it's with regards to the hospital system, not the sponsors or the clinical trials patient record. Although that should be obviously, I think, also a requirement, right?
Yeah,
We think about interoperability, right? With the data, with the obviously the patient's record within the clinical research project.
You know what we see is, for instance, currently we have a small clinical trial where today it's research, right? But the intent of the trial, for instance, in management of stroke patients, is that at a certain time, what they find out in a small-scale research project can go into the mainstream medical practice in hospitals, and of course, if you want to collect IoT data, let's say from 50 blood pressure monitors, just as an example, you can collect the data in a spreadsheet if you want, if that's the way you decide to collect the data and do graphs out of it. But then you might say, okay, how can I now deploy that to 10,000 patients monitored by 200 cardiologists who use Epic and MyChart? And then maybe these guys will tell you, I don't play if it's not in my chart. And then the question becomes, the interoperability question becomes, how do I integrate into Epic? What's the interoperability into Epic? And then you end up with talking to an army of people who are in charge of making sure there is no security risk, privacy risk, by having a new device, entering Epic in an uncontrolled way, right? So this becomes then a pretty big IT project, while maybe the clinical trial was like a small scale project, but the backend was Excel or a small database. While if you say now it's Epic and 10,000 patients, then it becomes another topic.
Okay. What about the considerations for security and privacy? I think for everyone, and Gio, of course. Obviously, when you're writing your research protocols, obviously you have to do a risk assessment. You have to think about all these things. How do you, I mean, obviously in your case, being a, device provider, in that case, the IoT, the provider, how does that sort of, without giving out too much detail, but the process, how do you factor in the risk assessment of the security and privacy using a third party, now another third party's device into the whole process? I mean, this is a big consideration, right? Because you already have a general risk assessment when you're writing your clinical research protocols, right? Your analysis, that kind of thing, and there's risks at every point, right? Safety considerations, obviously legal and compliance. And now you're integrating a third device into this, in a third party, which is the device manufacturer. And so what are the considerations that have to be thought of? Protecting the identity of the patients, right? The data that's being collected, securing the data, obviously the device itself, it can be hacked, right? Technically, it's the sensor or whatever it might be. I mean, there's all these different considerations. Anybody out there?
You're absolutely right. These are the challenges that we need to address. So want us to capture that, or?
I think that's important because it's in the, right, when we think about the starting of the study, maybe I think, and somebody had an interesting point there as well in the chat about ensuring that the identity of the person that the data is being collecting is actually that person. Like, how do you validate validate and verify that's the human that should be wearing that device and that kind of thing?
Yeah, we have that in the standard too. It's a very important piece of it. That's the trust and identity piece of it. And trust and identity, some of you might be familiar with the IAM term, identity and access management, which is usually, your MFA stuff, your multi-factor authentication. But now what we're talking about is, the device on the right human. Like I'll say, what if that little girl who was at the doctor with her grandmother takes the insulin pump and goes, this is really cool. I want to be a doctor, God forbid, right? And then there are these errant readings and it's connected to something that says, oh no, we're going to give them more insulin. Bad idea. So those are some of the challenges in trust and identity and crossing the chasm between the humans and the devices and the data. So you're absolutely right. That is one of the challenges that need to be addressed. And as identity and access management evolves, to have the humans more integrated, I think we'll have a lot of people from the IAM world that'll be able to help us. But I've been talking about this stuff for, 9 years now. I can't believe it. When we had the first workshop, I think with IEEE on end-to-end trust and security for IoT in DC, and DoD was there. I think there's somebody from DoD here as well. And, NSA and CIA, and a bunch of the 3-letter dudes and NSF and DOE. And, we were talking about what the challenges are. And this is actually a national security risk too, right? For any nation, because it's any human that can be involved. And so there's a lot that we've done since then, but there's still a lot to think about and worry about. And at the time, people doing identity and access management at the human level and at the IT level, not at the I have a device implanted in my body level. They weren't really ready for this, but now with the TIPPSS standard being announced, we're hoping that they are ready, and we're ready, those of us who are here, I think, and then hopefully we'll be able to do more about this together.
Absolutely.
Maybe if I can just add to this question, for instance, when a device is assigned to a patient, how then are we sure that that patient takes the measurement, etc.? We should not forget that in a clinical trial or in remote patient monitoring, it's a medical interaction between a doctor and the patient that is clearly driven by the doctor. So it's a digital therapeutic approach, and medicine, so to say, is not a pill, but it's in this case maybe a device that sends data, and of course there needs to be trust that it's the patient who takes the measurement, etc. So usually all these processes start with a declaration of consent, a kind of commitment of the patient that he wants to be part of that trial. So it's more or less a digital version of taking a pill. And of course, if your doctor prescribes you a pill and then you give it to your dog, okay, it's not very helpful for your health. And I think we cannot prevent all potential risks with just technology because there is this whole trust relationship that is the foundation of the therapeutic interaction between the doctor and the patient. And then the device is just a supporting element, right? And the data is just a supporting element.
You're absolutely right. And so it's like, how do we protect the humans from themselves or from their dog? You know, or from, you know, mistakes or errant things that happen. And you're absolutely right. Jill's, and the framework that you already have is so powerful. You know, I think you're a great role model already, as I said, for 2933 and TIPPSS. And now we can go deeper into it, you know, as we look at what else could be done. What are we missing? You know, as people look to deploy this in a jurisdiction, what other things are they going to be dealing with? And since this is a global standard, we don't specify all of those, but those are some of the local implementation considerations. There's actually a consulting firm that I met when I presented this at HIMSS earlier this year in March of 2024 in Orlando. And they want to do a proof of concept with one of their clients, which is great. That's how we're going to flesh this out. And we, you know, are looking at working with the manufacturers as well as, you know, there's going to be an opportunity for labs that actually can do testing of some of this stuff and testing of the solutions that are put together and some of the extensions that hopefully will create. And I had initially presented this to CMS and to NIST like a year and a half ago. And we said that when it's actually, you know, announced, let's talk about, you know, what else we can do to message it together and make it real. And I also spoke to the high trust guys, sorry, COVID brain, the high trust guys at HIMSS last year in 2023. And they were interested in knowing more after it's announced. So now that it's announced, and as some of you know, you can actually purchase the standard. Some of you did. Thank you for jumping into it. But when it's actually broadly available, well, it's broadly available if you pay for it. But, you know, broadly available as published, then, you know, we'd like to get the word out even more. So if there are opportunities where you would like to learn enough to present it yourself, you know, join the working group, or you can invite some of us. We do a lot of presenting on TIPPSS.
If I tie back, you know, the question of are we sure it's the person to the device? We had use cases in heart insufficiency where it's critical to monitor the spike in weight increase, right? Because this is the first sign of a decompensation by the patient. But of course, the weight scale, usually you put it in a bathroom. So in a bathroom, you might have, again, you know, the cat, you might put a luggage on it. You might have the grandchild who jumps on it because it's funny to jump on a weight scale. And then on the telemonitoring side, suddenly there are some stupid data points that come in. So we had such a situation in a real deployment of telemonitoring of heart insufficient patients. And to mitigate that data point, just the risk of misinterpreting this, one thing we did at a certain point, we put a firmware that said that this is a weight scale for telemonitoring of adult patients who suffer from heart insufficiency. So we put a firmware that said that any weight that would be measured below 20 kilo, you know, we don't even send it because it will just be noise for the doctors who receive it. Just as an example, how we can filter out with a work with the manufacturer on the firmware level, just to avoid the noise. But there are also other ways to go against that. Calibration, you know, the dog usually doesn't calibrate the weight scale, you know, the little tip, you know, like, so you can make the calibration of the weight scale mandatory. We don't send data if it hasn't been calibrated. So yes, this is also a way to avoid the stupid data But you cannot eliminate all risks, right? Never.
Yeah, you can't, like if it's a bull mastiff, right, that actually weighs more than is human. But the question is, how do you look at, the long tail, and then what could you do in that situation? But it's excellent. I love your practical advice, Jules. It's really great. And that's exactly what has to happen is the device manufacturers, the solution providers, and the users all talking about this together. And one of the things we're actually going to get started this year, and our co-vice chair, William Harding, who was formerly a senior technical fellow at Medtronic, he's actually leading the working group task group to create a maturity model around TIPPSS. And we'll be starting with the HIMSS maturity models and other maturity models. I did a lot of Smarter Planet, Smart Grid, Smart Everything work when I was at IBM in corporate strategy, and there was a Smart Grid maturity model from Carnegie Mellon University decades ago. So there's a lot of maturity model work that's been done. And one of the concerns we want to address is when people say, oh, but I have current technology. We're like, exactly. This is sometimes called, brownfield and greenfield, current devices that have been around and then new stuff that comes out. The standard applies to both. So how do people get on a maturity curve where they can look at where they are, do an assessment, and then see what they can do with the current devices to be able to accomplish, these TIPPSS capabilities. And then for companies that are starting with brand new devices and may not know some of the standards that some of you all know, from NIST or ISO or whatever, and they're not sure where to start, we want to make sure that they look at this holistically. As well as students. I've had some public health and IT professors that have said they'd like to bring this into their curriculum to teach their students to think this way, which would be wonderful, right from the beginning. And actually a couple of the Springer books that we have, if you're at an academic institution affiliated with Springer, you might be able to download the ebook for free. I'm so bad at selling what I do, but this is all mission-based. How do you learn about it? And then how do you actually help the humans, stay alive?
Excellent. Okay, so we have about, a total of 15 minutes, but I want to give, if anybody has any last minute suggestions so that we can capture them. You can also send them to me as well. I'm going to share my email address in a few seconds, but definitely you can share with it now, or you can write to us and let us know. Let's see.
I'm not looking at the Q&A. I don't know, Lauren.
I'm looking at both.
Okay.
I'm monitoring both. So I think one attendee wrote in the Q&A, communication protocols. Some devices uses certain communication protocols which may not work with a health center or infrastructure or investigative site, or depending what are the uniqueness of that environment. So I think that's an important consideration. And I know that's something Gilles encountered as well, for sure, in his work.
My question would be, is the device mentioned here in the hospital or outside the hospital?
Yeah, that's a good point.
Yeah.
I mean, we're assuming that the device, the patient, we're assuming is in a mobile or remote environment, right? That's the assumption here when we talk about remote subject monitoring. But, never make assumptions. All right, let's see. So I think we captured everything. So I want to just get these last points saved. Okay, everyone. So while we get these last points saved, I just want to let you all know that this is a 4-part series, and as soon as I get a chance, I will share my screen. Obviously, the first one today was on the remote subject monitoring and for clinical trials. Our next one will be in July, and I'll be showing that date soon, July 16th, and that's going to be conceptually on using this TIPPSS architecture for IoTs in precision agriculture. Obviously, same challenges there, lack of interoperability, concerns about security, cybersecurity, obviously impacting our food systems, even at the source. So we'll be covering from that side. The third one will be on connected vehicles. same concerns, a lot of data focused on obviously interoperability and privacy and security. And the final one will be on transactive energy. Same format, we're going to be doing a presentation with experts talking about real world scenarios, technologies, and then we get into this use case requirement building. Ultimately, as we share with you our goal, these are the building blocks to form what we call PAR study groups, which is going to help obviously the volunteers, all the volunteers develop the hopefully go into a standards working group at some point once all these use case requirements and ideas have been sort of formalized amongst the participants. But so let me just share with you real quick. So once I do this, the whiteboard will no longer be visible to everybody. So just know that. Okay.
I'm done.
No, she's like, I'm done. All right. So just find my presentation.
While you're looking for that, I just want to mention one other thing. Mark actually has, for brainstorming, looking at a digital twin standard. So I actually presented TIPPSS at the Virtual Human Global Summit, which was hosted by NIH, National Institute of Health, National Cancer Institute, Frederick National Lab, and the Department of Energy last fall in New York. And now I'm on the organizing committee for a virtual, for a global biomedical digital twin working group, which is kind of amazing. And so luckily I'm connected to that, and they do care about the TIPPSS standard. So so I'll be working on it from that perspective. And so I'm glad that you brought that up, and I totally agree that there's an opportunity there.
Awesome. I think we have quite a bit of different standards going on at IEEE around digital twins, either from technical discipline or looking at it in different applications. So very, very interested area from our volunteers for sure.
We've been doing digital twins. I'm an aerospace engineer, and aerospace engineering and car development and design for decades. So now we're like, oh, what about the human? So just like this technology, the security and the privacy and the identity and access management, now we're bringing it to the human. And that's the idea with TIPPSS. For those of you who are cybersecurity experts, you're probably thinking, where does CIA fit in? Confidentiality, integrity, availability. And from my perspective, I started in DoD too, like working on Navy aircraft many years ago. And, the CIA was pretty much created at the enterprise and nation state level. Now we're talking about technology and humans like normal plebeian humans in technology, and so we see TIPPSS being complementary to CIA, if you're familiar with that, and then extending into where the humans are, more physically involved.
Perfect. Okay, so everyone out there, if you want to get involved in this or the other areas that I mentioned, precision agriculture, connected vehicles, transactive energy, or if you want to get involved in all of them, that's great too. Just write to me, just drop me an email, and I'll definitely make sure you get included once we have the official PAR study group up and going. As I mentioned, these are the different workshops that are upcoming in the next few months. So agriculture is in July, connected vehicles in September, and then transactive energy in November. And since you registered, I believe at the time of registration, you had the choice to select which ones you wanted to attend. So you've perhaps already selected them. But if you want to go back and maybe you decided at first you didn't, you want to add it, you can do that as well. So just know that. For those of you in the Boston area, we're going to be doing a digital health tech forum. This is really highlighting the innovations of applications and technology development in obviously remote care, integrating data coming from the hospital system, obviously the concept of hospital at home. So that's going to be in Boston on the 30th of July. So if you're in the region and you have time, check it out, and hopefully you could join us in person. And, a lot of the work that we're talking about today is covered in different areas as well in incubation. So, we have the Transforming the Telehealth Paradigm, which is an incubation program, the Clinical Trials Technology Modernization Network, and the Zero Trust Cybersecurity for Health Technology programs. All of these programs are welcoming volunteers to sort of look at different opportunities to develop standards and to drive solutions. Obviously, exactly how we nurtured the 2933 standard. It was born out of a industry connections program. And obviously under Florence's leadership, it grew and actually to where it is now, and it graduated as a standard. And so a lot of these things happen here in these incubator programs. They're open. You don't have to even be an IEEE member to participate. If you want to bring your expertise and your time, definitely welcomed. And you can visit each of these websites, the ones that of interest to you, and you can express your interest and get involved. All right, so sorry, I lost my slides there. So with that, I would like to thank, obviously, all the panelists, especially Florence and Ryan, who came to this webinar with COVID and are fighting it to bring all to share this with all of you. But and I want to thank you, the audience, for hanging in there for almost a full 2 hours and bringing your great questions and participating in the brainstorming session. I think this is really the foundation and good start to taking the TIPPSS 2933 standard into all these different domains.
Yeah, and Gilles as well. I think his solution is prescient. I think it's very well done, and I think it's another good example, alongside with what Ryan presented. He's just the lucky one that didn't get COVID, so be careful.
Right. So, and obviously for me, Gilles is, I've working with him on different other areas. I think he has so many great applications, and so much great work has been done by their group. They're still, for a young company, they have done so many great things with cellular IoT. So kudos to them and their continued work going on right now. But for all of you, I want to wish you to continue to stay safe and well. And we look forward to you joining our next edition in July around IoTs and precision agriculture. All right. Take care, everybody.
Thank you.
Thank you. Bye-bye.
Thank you, everyone.
Thank you.
Stay safe.